will be doing Cayley-Hamilton theorem. Cayley-Hamilton theorem, what it says, every square matrix satisfies its own characteristic equation. Right? This is Cayley-Hamilton theorem. Cayley-Hamilton theorem is applicable only on square matrix. And what is that? Every square matrix satisfies its own characteristic equation. And now, if we know the characteristic equation, then only I can understand Cayley-Hamilton theorem, right? So I have told you, if a matrix A is given to you, then you will construct a matrix of the form A minus lambda I. This is your characteristic matrix. And then you will find determinant of that matrix A minus lambda I. When I am not equating this to 0, this is known as characteristic polynomial. And when I am equating this to 0, it would become characteristic equation. So this characteristic equation would be in terms of lambda. Let's say, for example, I am writing lambda square 2 lambda plus 1 is equal to 0. This is your characteristic equation. What theorem says? Every square matrix satisfy its own characteristic equation. So this was the given matrix. So this must be satisfy this characteristic equation. So what you will do? You will replace lambda with A. A square plus 2A plus identity matrix. Right? You will evaluate this left hand side. And if it is equal to 0, so it means this square matrix satisfies its characteristic equation. Right? Now, for example, verify Cayley-Hamilton theorem for the matrix A that is equal to 2 minus 1, 1, minus 1, 2, minus 1, 1, minus 1, 2, and hence evaluate A inverse. You can also find out A inverse with the help of Cayley-Hamilton theorem. So for verifying Cayley-Hamilton theorem, we need characteristic equation. So we will be making A minus lambda I matrix and then taking their determinant is equal to 0. So when you are making A minus lambda I, to probably you subtract lambda from these diagonal entries. So 2 minus lambda, minus 1, 1, minus 1, 2 minus lambda, minus 1, 1 minus 1, 2 minus lambda is equal to 0. Right? Now simplify it and let me know what will be the characteristic equation. Now solve it beta. 2 minus lambda into 2 minus lambda square and minus 1, then minus minus plus 1, this into this, minus 2 plus lambda, minus minus plus 1, and then plus 1, again 1 minus 2 plus lambda is equal to 0. Now simplify it and let me know what will be the characteristic equation. Take 2 minutes and simplify it and then let me know what equation you are getting. Are you doing now?
Yes, ma'am.
Okay. You need to find out characteristic equation only, beta. No need to find out roots.
Ma'am, may I?
Yeah, bachcha, sure.
Ma'am, it's lambda cube
Hmm.
minus 6 lambda square
Yes.
plus 9 lambda
Okay.
minus 4.
Minus 4.
Not sure about it, but yeah.
Okay. Thank you, beta. Anyone else?
Yes, ma'am. Same, ma'am.
Same.
Hmm. Same?
Yes,
Everyone
ma'am.
is getting same? Okay, let us check now. Okay, so I think we also have the same. Lambda cube minus 6 lambda square plus 9 lambda minus 4 is equal to 0. So this is your characteristic equation. Now what is Cayley-Hamilton theorem? Cayley-Hamilton theorem says this given matrix satisfies its own characteristic equation. So this is your characteristic equation. Now we need to check Cayley-Hamilton theorem is verified or not. So what will we do? We will put matrix A on the place of lambda. So it would become A cube minus 6A square plus 9A minus 4 is equal to 0. Will it work? Will it work, beta? Is it right? Is it right?
Yes, ma'am.
Okay, I'm telling you that there is some mistake. Find out.
Ma'am, it should be 4i.
Yes, it should be 4i because what is it? This is A cube. Matrix A and its cube. You'll be multiplying A 3 times. So everything is in terms of matrix. So you cannot subtract from when these matrix. So you need to write it here 4i. This is the mistake generally we do, right? So keep in mind when you are writing, when you are saying given matrix satisfying characteristic equation, so don't forget this identity matrix, right? So now you need to verify it. So for verification, what you will do, you will take this left hand side. You will simplify left hand side, and if this is equal to 0, it means Cayley-Hamilton theorem is verified, otherwise not, right? So first you will find A cube. To verify Cayley-Hamilton theorem, we have to show that this is equal to 0. So first of all, write matrix A and then find A square. Hurry up, find A square. find a square, a into a. So you will be writing here 2 minus 1, 1, minus 1, 2, minus 1, and 1, minus 1, 2. And again write it 2, minus 1, 1, minus 1, 2, minus 1, 1, minus 1, 2. Now find it out. A square. You will tell me a square value and then we will be checking out.
Ma'am, may I?
Yes, beta.
Ma'am, the first row will be 6 minus 5, 5.
6 minus 5, 5.
Second row will be minus 5, 6,
Hmm.
minus 5.
Okay.
Third will be 5 minus 5, 6.
5 minus 5, 6. Okay. Let's wait. Anyone else?
Same.
Same. Now let us check. It's 6 minus 5, 5, minus 5, 6 minus 5, 5 minus 5, 6. So this is your a square. Now next I need a cube. So we will taking this a square into a. This is a square into a. We will be multiplying and this is your a cube. Right? Note it down. A cube. Now put everything in left hand side of this equation. A cube, this value, minus 6 times of a square plus 9 times of given matrix minus 4 times of identity matrix. Write it over. We will try to write it here. 22 minus 22 minus 21 minus 21, 22 minus 21, 21 minus 21, 22. This is a cube minus 6 times of a square. So you will be multiplying with this 6, 36 minus 30 plus 30 minus 30 plus 30 minus 30 plus 30 minus 30 plus 36. This is also 36. 6, 6, 6, 36, 36, 36, and then negative 30 plus 30 minus 30 minus 30 plus 30 minus 30. And then plus 9 times of A. So 9 to the 18 minus 9 plus 9 minus 9 plus 18 minus 9, 9 minus 9, 18. And then minus 4, 0, 0, 0, 4, 0, 0, 0, 4. Now you will check it. 22 minus 36 plus 18 minus 4. Check it out. 22 minus 36 plus 18 minus 4. Is it 0? Is it 0?
Ma'am, there shouldn't be 22 in the in the second element of first row.
Second element of first row.
Yeah, ma'am.
You have calculated it?
Yes, ma'am. Yes, ma'am.
Anyone else have done it?
Yes, ma'am, it's minus 21.
It's minus 21, so it is minus 21, beta.
Ma'am, in A cube, first row, second column.
This first row, second entry, so this is minus 22, and you are getting it what?
Minus
Minus
21.
20.
Minus 21. एक बार क्रॉस चेक करो बेटा, एक बार रीचेक करो, otherwise it won't be for, I think, 0.
Ma'am, minus 21.
पक्का?
Yeah, ma'am.
मैम में 22 आ रहा है मैम.
किसका minus 22 आया बच्चे? We'll be multiplying this row, this column, so it would be 12.
मैं फर्स्ट रो सेकंड कॉलम की बात कर रहे हैं.
हाँ जी बेटा.
वेट मैम.
6 to the 12 and then plus 5. चेक कर लेते हैं चलो. Plus 5 and then plus 5. First entry is correct ना? 12 plus
Yes.
10, 22. Right. And then it's minus 6. And then minus 10. This row, this column, minus 10 and then minus 5. Yes, it is 6, 5, 21 आ रहा है तो गड़बड़ है. Okay, let us check it out. And
To
what
the
about
next element also, it should be plus 21, not minus 21. The next to it.
again 6,
Yes, ma'am.
then plus 5,
यस मैम. मैम प्लस
and then
21.
plus 10. Yes, it would be 21 plus. Okay, let us go with it. Are you sure ना it's your matrix A? कुछ sign mistake तो नहीं किया हमने? 2 minus 1 1 minus 1 2 minus 1. That's correct. Okay, then please check all the entries. बाकी भी check करो बेटा.
Ma'am, accepting them all are the same.
All are the same.
Yeah, ma'am.
So accordingly only there is a change of this minus 21 and this would be plus 21, right? So if I am talking about this 22 minus 36 plus 18 minus 4, this entry would be 0 na? 22 plus 18 is 40 and 36 plus 4 40, so this is 0. So in the result, eraser. So I'm writing here that is equal to, first entry is 0. Now check for the second, minus 21 minus minus plus 30 and then minus 9 and then minus 0. That's correct beta, right now? It's minus 30 plus 30, answer would be 0. So this is again 0. Now please check beta. Check for all entries. Are you getting 0?
Yes, ma'am.
Checked it beta.
Yeah, ma'am.
So this is a correction. It is minus 21 and it is plus 21, right? And then after simplification, you are getting all entries are 0. So I can say that left hand side is equal to right hand side. This means Cayley-Hamilton theorem is verified, right? So you need to write the characteristic equation, then put matrix A in that characteristic equation. For verification, you will be solving on the left hand side and that must be equal to null matrix, that is right hand side of characteristic equation. So we will say that this verifies Cayley-Hamilton theorem. Left hand side is equal to right hand side. I'll make it, it's minus 21 and this would be plus 21, right? Now, hence we need to find out inverse of that matrix. So what you will do, of 1 by A inverse. What is 1? This. Pre-multiplying with A inverse. So what it would be? A square, it would become A, and this is identity, and it would become A inverse. So I'm writing here A square minus 6A plus 9 identity minus of 4A inverse is equal to 0. Right? And from here, I can get the value of A inverse. So you are getting this, and from here you'll write 4A inverse is equal to A square minus 6A plus 9 times of identity matrix. And after that, we do have the value of A square as well as A. So we will be putting here 4A inverse A square minus 6A plus 9I, and simplification will be getting this. And finally, A inverse is equal to 1 by 4 times of 3, 1 minus 1, 1, 3, 1 minus 1, 1, 3. Right? I think all values will be correct. If you are getting any discrepancy, then kindly let me know. Right? Now, come to the next. So this was the verification of Cayley-Hamilton theorem and find the inverse of a matrix using Cayley-Hamilton theorem. Is it clear to everyone?
Yes, ma'am.
Okay. Now, come to the next. Diagonalization of matrices. Diagonalization of matrices. Let A be any square matrix, then P inverse into A into P is equal to D. A is diagonalization of a matrix A. This is a square matrix, and this is known as diagonalization of matrix A, where D is what? D is a diagonal matrix whose diagonal entries are eigenvalue of matrix A. And P is the matrix of linear independent of eigenvector of A, right? For example, this is a given matrix and you need to find out diagonalization of this matrix, right? So what you will do, first task, find the eigenvalues of this matrix, right? So you are having eigenvalues -1 and -2. I think you have done this question. It was our first example. This is your given matrix and these were the eigenvalues, and corresponding these are eigenvector when you are taking k is equal to 1. Then after that, you need to write out in this form. What is P and what is D? D is a diagonal matrix whose diagonal entries are given by eigenvalues. So you are making a diagonal matrix. Diagonal matrix means only diagonal entries would be there, and diagonal entries bhi kya hongi? Those are the eigenvalues of given matrix. So -1 and -2, so you'll be writing it -1 and -2, and rest of the entry would be 0. So this is your diagonal matrix. And what is P? P is eigenvector corresponding to these eigenvalue. So if you have written -1 in first column, so you will be writing first column of P corresponding eigenvector. So this is 4 and 1. Similarly, in second column you have written -2, so you will be writing corresponding column vector here, eigenvector here, 3 and 1. And what is P inverse? That is the inverse of this. So if I'm asking you the diagonalization of given matrix, so what you will do? First, you will find eigenvalue. Second, you will find eigenvectors, and then you will represent those in this form. P inverse AP, P inverse AP is equal to D, where D is given by this matrix and P is given by this matrix. Is it clear? Yes or no?
Yes, ma'am.
कुछ नहीं करना है. Everything you have done it. If I'm asking write the diagonalization form of this matrix, so keep in mind this is diagonalization and this is the diagonalization. So you need to write what is A. A is the given matrix. What is D? D is the diagonal matrix whose diagonal entries are represented by eigenvalues of this given matrix. You don't know eigenvalues thi, you have put it here -1, -2 and rest of the entry would be 0. Then what is P? P is the matrix of eigenvector corresponding to these values. If you are writing -2 over here and -1 here, then you will be interchanging these. जो entry आप यहाँ लिखोगे corresponding eigenvector would be here and whatever entry you are writing eigenvector would be here. If you are writing -2 here and -1 here, so this column would be 3 1 and this column would be 4 1. That's all. Right? Now come to next. Quadratic
Excuse me,
form.
ma'am.
Yes, बच्चे.
मैम मैम आइगन वैल्यूज में गिवन होगी मैम.
नहीं बेटा, you need to find out. Depends
Okay,
upon the
ma'am.
question. If I'm asking about in MCQ, right? I'm giving you this matrix and I'm saying that diagonalization of this matrix is given by this. Then what is D? Then what is D? तो मैंने D में आपको कुछ options दे दिए. Like this -1, 0, 0, -2. And another option I'm giving 1, 0, 0, 2. Likewise, 1, 1, 0, 0, -1, 0, 0, -1. So it should be clear to you what is diagonal matrix. Then only you can write the answer. So what you will do, matrix is given to you, you need to find out eigenvalues, and you know that in diagonal matrix we arrange the diagonal values on the places of diagonal entries. तो आपको यहाँ से पता लगेगा चारों ऑप्शन में से what is D? D is this. Why it is? Because these are the eigenvalues of given this matrix. Am I right, beta? And if I'm asking in the subjective, full-fledged, write the diagonalization of this matrix. So first task is find eigenvalues of this matrix. Second task is find eigenvector corresponding to eigenvalues. Then third task is you will write diagonalization form is given by P inverse A into P is equal to capital D, where D is represented by this matrix and P is represented by this matrix. Right? Is it clear, Harjinder?
Yes,
Sorry,
ma'am.
Harinderjeet Singh. Sorry, beta.
Yes, ma'am.
Chal. Now, come to the quadratic forms. A homogeneous means same. A homogeneous polynomial of second degree in any number of variables is called a quadratic form. Homogeneous polynomial of second degree in any number of variables is called a quadratic form. For example, ax square plus 2hxy plus by square. There are two variables, right? And this is second degree. Second degree. Homogeneous polynomial means every term is having same degree, that is 2. Degree of this term is 2. Degree of this term is 1 for x, 1 for y, 2. And degree of this term is again 2. So this is quadratic form with 2 variables. Similarly, if we'll be having 3 variable, then quadratic form would be ax square plus by square plus cz square plus 2hxy plus 2gyz plus 2fzx. Every term is having degree 2. 2, 2, 2 and 2, then 2 and then 2. Right? So this is your quadratic form with 2 variable, quadratic for 3 variable. Similarly, we can write quadratic form for 4 variable. X square, y square, z square, w square, 2xy, 2yz, 2zx, 2xw, 2yw and 2zw. So this is your quadratic form with 4 variable. Every term is having degree 2. 1y, 1z, 1x, 1y. So this is quadratic form with 4 variable, this is quadratic form with 3 variable, and this is quadratic with 2 variable, right? Now, how this quadratic form is written? You do have only this thing. So how I'll write it? If quadratic form is given to you and you need to write a matrix from this, so what you will do? I'm writing here x and and y, right? So this is x, this is x, xx or x square. So what is the coefficient of x square? That is a. So you will be putting here matrix A, right? And then xy and yx means xy and yx. Same thing. So you will be having this 2hxy. So what you will do? You will divide this 2h divided by 2 for 2 places entry. So this is h. So I'm putting here h as well as here h. Right? Next, y square. Y square, what is the coefficient of y square? B. So this place is filled by B. So this is how we write the matrix for quadratic form AHHB. Now I'm writing here, this is X and this is Y. This is your first one row and 2 columns, and this is 2 rows into 2 column. Product it, multiply it, and let me know what it would be. Hurry up, multiply it. Multiply this xy with this matrix. Product is possible. Number of columns here and number of rows here, both are same. So you will, product is possible. Now tell me what are the entries.
Ma'am, may I?
Yes, beta, please.
Ax plus hy.
Ax plus hy.
In the second row will be hx plus by.
Second row or column?
Ma'am, second row.
Y row?
Ma'am, because it no, okay,
Yeah.
I'm sorry. Hx plus by.
Yes. Just wait. Ax plus yh, and second one will be xh plus yb, right? Is it now? Yes or no? Right
Yes,
now?
ma'am.
Yeah.
Yeah, ma'am.
So it is. So output must be with 1 into 2. First row or 1 row and 2 columns. So you are getting 1 row, 2 column. And then you'll be multiplying this with again x, y. Right? 2 rows into 1 column. Again multiply this. So now what you will get here? You'll be multiplying this row with this column.
मैम ax square plus hy
Yes.
square
Yes.
plus hy square और मैम x square h plus y square b
Plus plus चलेगा नहीं? Plus x square h
h plus y
plus
square b.
y square b.
Yes मैम.
ax square नहीं बेटा गलत किया.
नहीं मैं hy square के बाद में प्लस नहीं आएगा. मैं वो
क्यों नहीं आएगा बेटा?
नहीं, यस यस, आई एम सॉरी, मैं गलत हो गया। AX
आराम से
AX
करो, कोई
प्लस
बात नहीं बच्चे, आराम से करो।
मैम मे आई?
यस बेटा।
मैम ax square plus 2hxy
2hxy ax square plus
2hxy
2hxy
y square
plus
y square.
by square.
Yes, ma'am.
By square, right? And this is first one row and one column. So this is 1 cross 1. And this is what you are writing here. Ax square plus 2hxy plus by square. Is it right? Right, beta? So this is how you can write it in the form of matrix. But now what you will do here, you didn't, there is no need to write, do the multiplication like that. The question will be asked, right? Write the matrix for this quadratic form. Write the matrix for this quadratic form. So you need to write out this matrix, right? And another way, if matrix is given to you and they'll be asking for quadratic form for this matrix. So if you know this matrix, and we will remember it like this: xx, yy, y. So xx, x square, so you will be writing ax square. So ax square, and then b, y square, by square, and then xy, yx. So h plus h, 2h, xy. So if this matrix is given to you, you can write the quadratic form, and if quadratic form is given, then you can write this matrix. Similarly, for 3 variable, let us have this quadratic form in 3 variable, and I need to write out matrix for this. So how you will write? Again, we'll be writing here x, y, and z. Now x, now you will be telling me entries in the similar manner like we have written here. Now tell me, what will be the first entry? Xx means x square coefficient. What it would be
A.
Ma'am,
from here?
A.
A, right? Then y. In this entry, y square. What will be the coefficient of y square?
B.
B.
B. So we will be writing here B. Similarly, z square. The z and the z, this would be your zz. So coefficient of z square is C. Right? Now, next is xy and yx. Tell me the entries for this place and
ma'am,
this. Yes.
h.
H, right now 2hxy. So we will divide this 2h equally at for these two places. So this is h and this is h. Now next xz and zx. Zx?
F.
Yes. So we'll be dividing this f here and f here. Similarly, now yz and zy.
G.
G, na? 2g. We will divide it. This is G and this is G. Now check AHF, AHF, HBG, HBG, FGC, FGC. Right? If quadratic form is given to you, you can write the matrix, and if matrix is given to you, then you can write quadratic form. Right? So if you need to write out the quadratic form, so you'll be writing A x square plus B y square plus C z square plus 2h plus 2f zx plus 2g yz. You will read them corresponding to their places. Similarly, for quadratic form in 4 variables. Now, let us have an example. Write the matrix for the following quadratic forms. Now, you write the matrix for this quadratic form. Write it, hurry up.
एक्सक्यूज मी मैम।
Yes, beta.
मैम जैसे में हमने मैं मैट्रिक्स से मैं क्वाड्रेटिक इक्वेशन लिखनी है तो मैम क्वाड्रेटिक में एक्स वाई वाई जेड में आगे पीछे हो सकता है।
किसमें बच्चे इसमें?
यस में जैसे में मैं
हाँ,
मैट्रिक्स से
2h xy है तो चाहे आप 2h yx लिखो, हार्डली मैटर। तो प्रोडक्ट में है ना
ओके
बेटा, xy लिखूं या yx लिखूं एक ही बात है।
ओके मैम थैंक यू
ठीक
मैम।
है? चलो, write the matrix for this quadratic form. Yes, who will tell me?
Ma'am, may I?
Shubham beta, wait.
May I?
Yes, Niharika.
मैम पहले तो एक्स वाई जेड आएंगे कि मैं मेन मैट्रिक्स बताऊं 3 by 3 की।
हाँ, ये हम अपनी कन्विंस के लिए लिख लेते हैं, x y z and x y z. Yes, now tell me the entries beta.
1 1 3।
1. Okay, tell me diagonal entries first.
ओके मैम 1 and
1
5
5
1
1. ठीक है, we have done x square, coefficient of x square is 1, y coefficient of y square is 5, z coefficient of z square is 1. Yes, next beta.
मैम नेक्स्ट मैम
Means
एक्स
yes,
वाई कोफिशिएंट मैम 1
it is 1 and corresponding yx would be 1,
1।
right now?
यस मैम।
And then next
देन
xz,
नेक्स्ट एक्स जेड कोफिशिएंट वुड बी 3
yes, good, it's 3
एंड देन
and
corresponding would be 3।
this is again 3, yes.
Can it also be 4 and 2 because the sum would be 6?
No beta, you need to divide it equal place, equal part, divide by 2 only.
Okay ma'am।
Okay.
And
Because
then
this
entry
matrix,
would be
after that you will observe that this matrix is a symmetric matrix, so you need to make it symmetric.
okay ma'am।
Okay.
And then entry for yz
Hmm.
would be 1
1
and the
and
corresponding would be 1 as
1.
well।
Okay, so you can say that is it symmetric?
Yes ma'am।
है ना? Row and column, when you will change it, it will remain same. So this matrix is always symmetric matrix. Okay, now go for second question. 1 1 3 1 5 1 3 1 1. It was right answer. Okay, now go for second question. अभी वो बच्चा आंसर देगा जो कभी आंसर नहीं देता, ठीक है? अभी शुभम, सात्विक, निहारिका, इशिता, यशिका ये नहीं देंगे. Anyone else?
मैम डन।
I'm done.
Okay. Harinder done. Another one.
यस मैम डन।
Kshitij.
Kshitij. Okay, Kshitij, your mic is working.
Yes, ma'am. In middle, sometimes it does not works.
Okay, but luckily it is working right now, so you tell me answer.
Ma'am, diagonally it will be 353.
3 5 3. Harinderjeet, you will check it, beta. Okay. Yes, beta.
Okay,
3, 5,
ma'am.
3. Then what?
Ma'am, and xy will be 1
1. And this is
and
1,
y
right?
is also 1.
Tell me this entry, bache. XZ.
Ma'am, which one?
This entry, beta. This one. And this one. This is
Ma'am, it
it.
will be 1.
Okay, it will be 1. This is 1. This is 1. Okay. Now this.
Ma'am, it will also be 1.
Everything is 1, 1, 1.
Yes, ma'am.
No, ma'am.
Okay.
मैम एक्चुअली आई एम कंफ्यूज मैम कि ये माइनस का क्या होगा
Minus का minus होगा. You will be dividing minus 2 at 2 places. Minus 1,
ओके
minus
मैम
1, that is minus 2.
ओके मैम मतलब माइनस दोनों जगह आएगा
Yes, दोनों जगह minus आएगा.
ओके
ठीक है? So I think xy, this is minus 2, so we'll be taking here minus 1 and it is
यस मैम
minus
इट्स
1.
माइनस 1
And another is yz. So this yz, this is minus and this is minus.
माइनस यस मैम
ठीक है. अगर आप एक जगह माइनस लगाओगे दूसरी जगह नहीं लगाओगे then this matrix won't be symmetric matrix.
ओके मैम
है ना? And this matrix should be symmetric matrix.
ओके मैम
Harinderjeet, is it right, beta?
Yes, ma'am.
Okay, chalo, good. So this is our answer for second question. 3 minus 1, 1, minus 1, 5, minus 1, 1, minus 1, 3. Now, next, write quadratic form for the following symmetric matrix. Do it, hurry up. Yes, who will give the answer?
डन
Hmm.
Done, ma'am.
Okay, Harinder, you will check, beta. Okay? Someone else will give answer. Abhinav.
Okay, ma'am.
Abhinav,
डन मैम
46 ID.
Ma'am,
Yes, beta. Tell me the answer.
ma'am, just wait a second.
Okay. Take your time. No issues.
मैम मैं बताऊं
Okay, Hitesh. Tell me.
मैम 4x²
4x square
प्लस 6y²
plus 6y square.
प्लस 7z²
Yes.
माइनस 4xy
Minus 4xy
प्लस 2xz
plus 2xz
माइनस 2yz
minus 2yz. Yes, Arjinder. Check karo beta. Is it right? Harinderjeet?
Yes, ma'am. It's correct.
It's right now. So x,
Yes, ma'am.
y, z. Y and z. So you're writing 4x square, 4x square, 6 y square, 7 z square, right? And then for this minus 2, minus 4 xy, then 1, 1, 2 zx, so 2xz or zx, one and the same thing, and then minus 2 yz. This is your quadratic form. So now you are able to write quadratic form from given matrix, and if given quadratic form is given, so you can write matrix from that. Right? Now, next, nature of a quadratic form. A real quadratic form x dash ax in n variables is said to be positive definite if all eigenvalues of matrix A greater than 0. This is your matrix A. See, this is X transpose and this is X. So what you have done here now, this is what X and it is X transpose. And this is your matrix A. If eigenvalue of this matrix all are positive, strictly greater than 0, then that is positive definite. Nature is positive definite. If all the eigenvalues of A strictly less than 0 means all are negative, then this is known as negative definite. If all the eigenvalues are greater than means all are positive, at least one eigenvalue is equal to 0, then that is known as positive semi-definite. And if all are negative and at least one of eigenvalue is 0, then this is known as negative semi-definite, right? Because all are less than 0, it means it is negative. Definite or semi-definite difference is if one entry is 0, then it would be semi-definite. If all are negative, no one is 0, then that is negative definite. Similarly, in case of positive, x 0, it means it is positive semi-definite. All are greater than 0, then that is positive definite. And it is indefinite if some of eigenvalues are positive and some are negative. Then nature is indefinite. Right? Now, next is reduction of quadratic form to the canonical form. Reduction of quadratic form to the canonical form. Quadratic form is this A and X, X dash. We know that we have done this, X dash AX. In 3 variable, this is your quadratic form. And you need to write out canonical form. How to write it? Canonical form of a matrix is given by lambda 1 y1 square, lambda 2 y2 square plus lambda 3 y3 square. These y1, y2, y3 are another variable. We have taken yi just to make the difference from x, y, z. Okay, बस variables है, nothing more than that. So canonical form you'll by writing lambda 1 y1 square, lambda 2 y2 square plus lambda 3 y3 square. And what are this lambda 1, lambda 2 and lambda 3? These are eigenvalues of this given matrix. Right? Suppose this quadratic form is given to you, right? And I'm asking, write the canonical form for this quadratic form. Right? My question is, write the canonical form for this quadratic form. So what you will do? First task, you will write a matrix from this quadratic form. Right? And then you will find eigenvalues of this matrix. After getting those eigenvalues, you will represent in the form of canonical form. First eigenvalue, let us say you have written this matrix and you are getting eigenvalues say 1, 2, 3. So how you will write? You will just write like y square plus 2y2 square plus 3y3 square. That would be your answer. This is the canonical form of given matrix. If you know how to write a matrix from the quadratic form, then only you can write this. You can do this question. And after writing the matrix, if you know how to find the eigenvalue, then only you will be able to write the canonical form of a matrix, given matrix. Right? So for quadratic form, you will be writing a matrix A from the quadratic form, then you will be finding the eigenvalues for that matrix, and then you will write the canonical form. Right? Now, for example, write the canonical form of this matrix. आपके पास quadratic form से matrix already बनाकर दे दी है. Now your task is Find the eigenvalues. Because this is what type of matrix?
Upper
What type of
triangular.
matrix? Upper triangular. So
Upper
either of
triangle.
upper triangular, lower triangular, or diagonal matrices. In all three cases, diagonal entries would be your eigenvalues. So eigenvalue of this matrix 3, 5, and 3. So now you need to write out canonical form. So you'll be writing 3y1 square plus 5y2 square plus 3y3 square. So this would be your canonical form for this given matrix. Right? So that's all for today. Any doubt?